Okay, so the polynomial that passes through that point, actually that's g of x, isn't it? I think. Just have a quick look. Yep, g of x. Okay, so the first thing you'd have to do is a uv. So u equals x, v equals g to the minus 1 of x. U dash equals 1 and v dash equals the derivative of g to the minus 1 x. Now, to get g to the minus 1 x, you need to understand that g to the x equals x cubed plus 4x minus 2. So let's make that y, x cubed minus 4x minus 2. So to get g to the minus 1 x, you need to swap the x and the y and solve for y. Okay, but if you did that, y cubed minus 4x minus 4y minus 2, it's too hard to solve for y. So then you realise, well, hey, I don't actually need to find the function. What I need to find is its derivative. So you find dx on dy, which is 3y cubed minus 4, and the 2 goes to 0. And then you find dy on dx, which is 1 over 3y cubed minus 4. Okay, so we're now looking at that, and we're doing that at the point. Now the point is 1, 3, right? So we're going to find the gradient of the tangent at that point. So the point 1, 3 on g of minus 1x becomes 3, 1, because you have to swap the x and the y. So therefore we want it at the point where y equals 1. So, and x equals 3. Okay, so that means that, sorry, I've written that wrong, that should be dy on dx. Because if you think about this is dy on dx, because that was the flip version. Come back here, you find that first, then you flip it, and it's dy on dx. So it's at that point, but it's going to be really at the point 3, 1, because you've also got to swap the x and the y value of the point. Okay, so let's see. We want x, g to the minus 1 x. We want the gradient of that. So u equals x, u dash equals 1. V equals g the minus 1 of g the minus 1 of x. Okay, so this is g the minus 1 of x, and this is v dash, which is d dx of g the minus 1 of x. Okay, so if we found the derivative of this would be x times the derivative of g the minus 1 of x plus 1 times g the minus 1 of x. So that's going to be x times the derivative of g the minus 1 of x plus 1 times g the minus 1 of x. Now, we want this at the point 3, 1, because originally it was at the point 1, 3, but because we're after the inverse, we need to swap it. So that's when x equals 3 on this, on the g the minus 1 of graph. So when x equals 3, it's going to be y dash. That's going to be 3 times. Now, the derivative of g the minus 1x, if you go back, is 1 over 3y cubed plus 3. So the derivative of g the minus 1x is 1 over 3y cubed plus 4. And we want that when y equals 1. So y equals 1 would be, and that's x equals 3, 1 over 3 times 1 cubed plus 4, which is 1/7. So that's going to be 1/7. And g the minus, so that's going to be 1/7 plus g the minus 1 of minus 1. Okay, so if you're looking at that there, that means on the new graph we are after the y value. Okay, so we go x equals y cubed plus 4y minus 2, and we want to know what would the y value be on this new graph when x equals 3. The y value would be 1, so it's 1 times 1. So that's g the minus 1 of 3 actually equals 1, because on the new graph the x and the y are swapped. So finally that ends up being 3 on 7 plus 1, which is 1 3/7, or 10 on 7.